All right, so two plots are given here. Let that load up. Two plots are given, one on the left, one on the right. First thing I guess I want to hear is whether it's, like you just mentioned, is it positive or negative correlation? And how do you know? And then is it strong, moderate, weak? Any of those words kind of make sense to you here?
So 3 is kind of like, I'd say like a kind of moderate positive correlation.
Okay.
And then 4 is a strong negative correlation.
Okay, I agree. Now let's go a bit further here, and the wording does matter. So let me try to make up, and let's forget about the scales here. Let me just give some. Let's talk about. Let's say this is pages read in a book, and hours spent reading. Okay, how would you turn this into sort of a what they say an interpret? How would you interpret this information? And there's certain language they're looking for.
What I would say, which probably isn't correct, would be like the more pages you read, the more hours that are spent reading them.
Okay, good. So they're looking for certain words like as pages read increases. They're usually looking for that word increase or decrease. You can similarly say something about time spent reading. Time spent reading increases. So they're looking for increases, or those words, and they also want the actual quantities that you have on the variables here. Okay, so let's look at the one on the right here. Let's go temperature, and then we'll do the boring one that they always use. Let's go ice cream sales. Oh, sorry, that's not correct. Hot chocolate sales.
We actually had a problem that did that.
Yeah,
Yes,
it's kind of the traditional one. So how would you describe hot chocolate sales and temperature in terms of like increases, decreases, increases? How would you maybe, based on what you've got over here on the left?
So as the temperature decreases, the sales in hot chocolate decrease.
But as you're going to the right, the temperature is increasing. Like think that this is like 10 degrees and this is 100 degrees. So as you're going to the right, temperature is increasing. So with strong negative, as one variable increases, the other decreases. So as temperature increases, hot chocolate sales decrease. So like this point over here means it's 100 degrees and maybe there's 20 hot chocolate sales, whereas this point up here at the top is 200 hot chocolate sales for 10 degrees. So the takeaway from this should be that when you have positive correlation, it's increase, or decrease. And you might have even seen this in class there. It's considered in the same direction. Like as one goes up, the other goes up. But as one goes down, the other goes down. They go in the same direction. So what that means graphically is as you spend less time reading, you read less pages. That's this downward. I feel like maybe that's not clear, especially the down stuff.
I mean, it is. It's just confusing when it comes to like negative, the way you word it.
Yeah, I mean, the negative correlation is just a word that they use in this part of the course. It's not actually referring to like negative numbers. It's referring to really what's called inverse, which is as one increases, the other decreases.
Mm-hmm.
And if one is decreased and the other increases, this is considered opposite direction.
Okay.
Okay. All right, let's look at a couple more graphs. Let's look at one here on the left. All right, let's start again. Do you think this has positive, negative correlation, and is it strong, weak?
I think it's weak, but I can't tell if it's positive or negative.
This is where you might have to connect a few lines. I know that's maybe hard to do on the the computer screen, but you can sort of run your finger. Say, okay, could that be a line? Could that be a line? Basically, do you see is there any possibility where there could be a line going down and to the right?
No.
Probably not. So what would this be? What would this be? Positive?
Positive.
And is it strong, weak? What would you say?
Weak.
It is strong. I'm sorry, it's weak positive. Yes. Okay. All right. So this kind of situation represents something where basically people wait until the end to start doing it. You know, like you think of this as days of school, and then preparations, study time. So it's like you really aren't doing much, and then you hit the 100th day of school and you're like, oh boy, I better start studying a bunch here. All right, let's look at another graph here, do the same thing. Does this have positive or negative correlation and why?
Positive.
Okay, how do you know?
Because of the 3 dots that can, like, you kind of can put a line through them in the middle.
Like this? Oops, that's moving the page. Oh no, don't do that. Okay, there it is. So something like this.
Mm-hmm.
But couldn't you also do the same thing for these 3 dots, roughly?
Yeah.
So the issue here is like there is no clear trend. You really need to see the data points following a progression, one way or the other.
So no correlation.
Yes. So there are 3 graphs that you have to remember, and this is let me show them to you here. So this kind of like closes out this part of the of it, but this one is that I've shown on the left here is positive correlation. I'll write these down. Next one is negative correlation. And the last one is what you just mentioned, which is no correlation. Okay, so just because you can draw a line where half the points are above and below it is not enough. Positive, negative, and no correlation. Thoughts on that, or?
Mm-mm.
Okay. And the interesting thing is, I think, is we actually try to do this. Like, we think if we study more, we'll get a better test grade, or if the temperature goes up, then something else. We tend to think that like one causes the other, one affects the other.
Mm-hmm.
So let's look at a new problem here. This one has positive correlation. Okay, you can see that it's kind of going up and to the right. It's following a trend there. And I want you to put a sentence together that talks about the number of number of ticket writers and the number of tickets. If they're positively correlated, I'm looking for something that says as blank, as one of these variable either increase or decreases, then the other variable increases or decreases.
So as the number of ticket writers increase, the number of tickets issued increase.
Yes, yes. Very good. Now it's really easy to do when you have a plot. Would you agree with that?
Mm-hmm.
But you're going to get some problems where you don't have a plot. So what I would like you to do on your paper there, I hope you got some paper, make a really rough sketch of this. Okay. It doesn't have to be to scale. The actual, which variable goes on which axis, believe it or not, does not matter. I know that's been like told to you for a long time. Like it really matters what variable you have. Not the case here. So I want you to make a quick sketch of this and then tell me whether it has positive or negative or no correlation and whether it's strong or weak.
Mm.
Which did you plot on the, like, which did you call the x-axis?
Number of students.
Okay, so students, and then free throws.
Mhm. Was the Y.
Okay, and that really doesn't matter. I'm just asking so that I can graph it here. You know, 7 3, 2 1, 6 6, maybe.
Yeah, it's almost
4.
like you can make two lines and then there's like one dot that's like out there.
5 2. So this one I probably should have done a little more accurately, but there's that. 3 4. 3 4. Let's see. I guess that'd be somewhere in there. All right, and then 1 3 1 3. Okay. So this one's tough here. So here's a strategy you can use that they might not even show you in class is to put the x values in order. All right, so like 1 and 3 would be first, then 2 and 1, then 3 and 4,
Mm.
4 and 7, 5 and 2, 6 and 6, 7 and 3. Now the reason you do this is because now you can see that as this one goes up, do you see a trend of this one going up?
No.
No, I don't, and I don't either. I see it sort of goes up and then down. So
Doesn't.
I'd probably go no
No
correlations.
correlation.
Okay, and that's a strategy you can use to decide, because sometimes plotting it doesn't tell you. You really need to look at the numbers in order to see if the other ones are going up. Now, let's just say I modified this slightly, because I think sometimes seeing the exception isn't all that helpful for learning. But let's say this was 12, 16, and 13. Do you now see more of a trend of increase?
Yeah.
And then it would be more of like, okay, yeah, maybe there is. All right, so one more of these. This is multiple choice here. All right. So this is kind of like SAT stuff as well. I want you to read the information about the graph on the left and choose the information answer that's on the right there for the interpretation.
Is it B?
As traffic volume increases, vehicle speed decreases. So this is a down, a negative. That means they're going to go in opposite directions. That's looking pretty good. As volume increases, vehicle speed decreases. Yes. Now, are you driving yet by chance?
I have my permit.
Okay. Have you been out on the road much?
Just on like back roads.
Okay. All right. Well, we could, sometimes we have to change the problem. It's like as the amount of um, the the amount of noise in the room increases, the number of pages that you read decreases. But that's great. It's great that you got it. I was just curious to see if you'd experienced this on the road yet, because it is true. You can always drive faster when there's less people on the road, because
Yeah, I
there's
mean, yeah, my mom she always has the car if I needed it because she like works a lot and she likes to go out at night. So if I needed it, I don't have it.
got
And
it.
then when I do, she's always with me. So it's like, let's just go to the back roads or like the store right here. And I'm like, okay.
Well, better to be safe than anything else. So here's a new question. So here's something we've not done much of, which is here's a regression with a line through it, and then you using the information here to decide, are they giving you X to find Y, or are they giving you Y to find X? So take a look at this and see what you come up with.
B.
Okay, and how confident are you in your answer?
A little bit.
Okay, are they giving you are they giving you X or Y here?
X.
So here's 9. So we basically go up to where we can hit the curve, which we have to kind of extend, and then you kind of bounce off it and go left. And I agree, that's pretty good. All right, let's do one more. Then we'll switch over to absolute value, unless you've thought of something else you want us to work on.
Mm-mm.
All right. Okay, sorry, just trying to frame the question here. So this time, and I know this is hard because you don't have the thing in front of you, but kind of eyeball it, or visualize a line and
5.5 or
A, B,
6.
C, or D. So are you doing that because you went up here and you hit 5.5?
Yeah, C.
So what I want you to think about is like, what would the line of best fit look like? And I know that without having it on there, it's not all that easy to do. Like my question to your thought for you is like, does the line look like this, or is it kind of more biased to, I can't rotate it. Is it kind of more biased to where it's somewhere like that?
I feel like it's mm,
Like maybe a little more up?
Yeah.
Okay, and that's fair. You're kind of looking for half the points above and below. So maybe something like that ish.
Mm-hmm.
Okay. So at some point you say, okay, I've got it. That's what it is. And then you go up and bounce off it. So since that answer isn't there, what's the most reasonably close one to it?
6.
You already answered that, yeah. And by the way, this is an SAT type question you might see. There are questions on there that are this really trivial. You just go up and bounce off and hit it. Hit the other one. Is there anything else on scatter plots you would like us to talk about?
Mm-mm.
Okay. The last thought I will give you, and hopefully you guys have been talking about this in class, is that correlation does not imply causation. Have you heard that in class?
No.
Okay. Well, that's not good. All right. We should just spend a few moments talking about this. This is like the most important thing that you would want to take out of this. So this, let's take something that's really, really unbelievable. Could never happen. All right. So this is pages. And this, by the way, do you go by Alexis or Lexi? I'm sorry if I've messed that up. Do you have a preference?
Alexis.
Okay. So let's say this is pages that you read in a week. And this is Matthew's, that's me, golf scores. Okay. And let's say it looks, we plot some data and it looks like that. Would you say that these two things are correlated?
No.
Wait a second. What does the graph show? Does it show a nice kind of around?
Yeah.
And that's what correlation is.
The
What you
two
were refer,
subjects don't though.
say that again?
The two subjects don't though.
Right, they don't go together. That's the causation part. Okay, but are they correlated? Like, do the data
Yes.
show that they trend? Yeah, but what's wrong? Like, can you say that one affects the other?
No.
No, because why would that even matter, right? Why would like what I'm doing impact your reading or vice versa?
Because you tutor me. I'm kidding.
Maybe, right? No, I mean that doesn't, but sometimes it can be questionable. It can be like, well, does it impact or does it not impact? I think I remember you guys had something in classes, because I know I'm probably helping some other students, something on like boating and skiing. Did you see something like that in class?
Might have been in a different class.
Okay.
Because there's like 3 or 4 different Algebra 1 teachers.
Yes.
But
Okay.
my teacher kind of does like whatever he wants.
Okay. So let's look at something else. Let's say it's vegetables eaten, or quantity of vegetables that you might eat, and days until prom. Okay. So this again shows a correlation, right?
Mm-hmm.
Now, why would there be causation? Why would the days until prom maybe affect the quantity of vegetables that a person would eat?
Because they want to eat healthier
They want to eat healthier, right?
to
So
look better.
sometimes correlation can mean causation. But the mistake is, and this happens all the time, you can ask your mom about this at her job, or other people. Like, you'll go to a work meeting and someone will throw up data and they'll say, this variable causes this variable. We need to do more of this variable or less of this variable to do this variable. And they have forgotten their basic algebra
Yeah.
1, that correlation does not imply causation. Because you can literally show correlation between really anything that has nothing to do with each other. And that's what I was trying to talk about with the golf scores and your pages that you read in a week. They're not related, but they could be correlated.
Mm-hmm.
So just be very careful about that. All right, let's move on to absolute value.
Okay.
We'll just take a 30-second breath here. All right. Can you tell me what this represents? If you know, if you don't, that's okay.
It's the form A is kind of like, I guess you could say kind of like the slope, and
Yes,
then
agreed.
the H and K is your vertex.
So A kind of refers to slope, but H comma K for sure are the vertex. That's good. It's really good. A also tells you whether it opens up or down. Do you remember that? How you decide whether it opens up or down based on the A value?
Negative or positive?
So if it's positive, it opens up. Down, it opens negative. Or down, it's negative if it opens down. Or it's down when A is negative. Okay. Great. So let's look at an example here. Y equals negative 1/3 x plus 2 minus 5. Can you give me the vertex, please, for this?
Would it -2 and 5 or -5?
Yes. Very good. Does this open up or down?
Down.
Down. So without having like a lot of information, you can do the following. You can say, okay, -2, -5, like that. And then slope, you can kind of roughly sketch that like this. Okay. So just based on the graph, does this graph have a y-intercept?
Yeah.
It does. In fact, they always have a y-intercept for most functions, most polynomial functions like we're doing here. Does this have an x-intercept?
No.
No. So it doesn't always have an x-intercept. If I change this to positive 1/3, how would that affect this graph?
It would flip it up, and it would actually, would it cross the y-axis?
Yes, it always crossed the y-axis. So the
Or,
way,
I mean, X. Sorry.
yes, it will eventually, even if it's the most wide thing here, it will eventually hit the x-axis. All right, so what I'm doing now is looking for some practice problems that have some features that make this easy for us to sort of work through, where they don't have a lot of weirdnesses. All right, let's do something super simple. All right, here we go. Absolute value x plus 5 minus 2. Can you tell me the vertex of this?
Um, -5, -2.
Very good. So make a rough sketch and tell me if it has x-intercepts or not.
Um, I think it would cross it eventually, but I don't see one. What is
Well,
the
so
A just one?
it is, yeah. And so it does open like maybe not to scale, but you want to see that if it's below the x-axis and it opens up, it will eventually cross.
Mm-hmm.
And similarly, if it's above the x-axis and it opens down, it will eventually cross. There's sort of some parallels to driving. If you stay on the road long enough, you eventually get there. All right. Is that okay? Because we're going to do a little bit more here, but I don't want that to be unclear.
No, it is. I was just like, I don't, because it opens up and I didn't know if the A was one or not. So if I was
Got it.
opening up, but if it
I
was
see.
opening down.
So if it's opening down, then it would never cross the x-axis. Okay. Does it cross the y-axis?
Yeah,
Yeah,
eventually.
eventually. Okay, so there are two things that you are going to be asked to find. The y-intercept, which is when x equals 0. You're putting 0 in for x. This is the one that students like. Could you do that for me? Could you put 0 in for x, add 5, absolute value, and subtract 2?
Like solve it or graph it?
Just put 0 in for x to get a value. Let me, I realized maybe I wasn't being clear. This is what I'm asking you to do.
Kind of stuck.
Okay, let's go through this together. 0 plus 5. What is 0 plus 5?
Oh, 5.
Okay, and the absolute value of 5?
5 minus 2.
Yes, so the absolute value always returns positive.
And then it's 3.
Yes. So what this is saying is that when x is 0, let me highlight this. When x is 0, y is 3.
3.
And that's an ordered pair on your graph like that.
So that's the y-intercept.
That's the y-intercept 0, 3. All right, so let me give you another one here to think about, or give me the y-intercept for before we move on to the x-intercepts. I'd like you to calculate the y-intercept, which again means to put 0 in for x.
Would it be 4 times 3 plus 1?
Yes.
So 13.
Yes. Good. Okay, let's go back to the previous problem that I gave you, and we'll talk about now how to find the x-intercepts. So we just looked at this one. Just want to give you another example of that. So to find the x-intercepts, and this is the more difficult one of the two, you set the function to 0. So basically, instead of this f of x, you put a 0 there. Okay, and if you don't like the 0 on the left, you can move it to the right. That's allowed. It's like changing the settings in your car when you drive. You kind of want to get the seat right, all that stuff. You want this to look the way you expect it to look.
Mm-hmm. So would it be x plus 5 equals 2?
That's one of the solutions. So when you solve an absolute value, you first set it equal to 0 or equal to the number, and then there's two
Mhm.
cases, case 1, case 2. And you've mentioned one of them. What is the other one, if you recall?
X plus 5 equals -2?
Yes.
Or X minus, yeah.
Okay, so go ahead and solve this for us, please.
X equals 3 and X equals 7.
Subtracting 5 from both sides, is that right?
Mm-hmm.
Okay,
Oh,
so
wait, 5, not 2. Oops.
so sometimes money is a good reference point for figuring out the sign of the answers.
Is it the opposite, like X equals 7 and X equals 3?
Just okay, so 2 minus 5, that's where we're at. And think of it in terms of money. 2 means like you have $2. Minus 5 is you owe someone $5. When you hand them the $2, how much do you owe them?
3.
You owe them 3. And think of, like, I interpret that, you think of negatives as owing, positives as having. So you're like, you might be thinking, well, how can I do it if they're both negative? Well, this is a bad situation. You owe someone $2 and then you owe them another $5. Now you
7.
owe them 7. Yeah. Not ideal, but hey, it's so there's 2 things that they're going to ask you to do, which is to find the y-intercept like we did in the last 2 problems, setting x to 0. And then the other one is to set the whole function equal to 0 and find those values. So let me give you another one to think about here, talk about. Of course, I lost it. There it is. All right. So new function here. Go ahead and give me the vertex.
-1, 6.
Okay. Now I want you to make a quick sketch of this, plotting the vertex, whether it opens up or down, and tell me if it has x-intercepts or not.
It doesn't have any x-intercepts.
So is this where you put your vertex point? Roughly?
Oops, I did -6.
Okay.
It does have an sub.
Yes. Okay. So sometimes it's good to like know what you're looking for in advance. Can't stop and make these references to driving. It's like, do you know where you're going? Does this thing have x-intercepts? It does. So we're going to find those. We're also going to find the y-intercepts. Let's do the y-intercept first. That's where you're putting 0 in for x. All right. So go ahead and work that out for us. The negative comes after you take the absolute value. Keep that in mind.
Would it be -7?
Close, real closer. So it's negative absolute value 0 plus 1 plus 6, absolute value of 1. Okay, so the 1 becomes positive 1. The absolute value always returns positive, but then you apply the negative. You're only applying it to the absolute value though. So this plus 6, notice how it comes down
Right.
each time.
So you wouldn't change it so it'd just be +7?
Nope, you owe someone $1, but you have $6.
5.
Yes. Go the money route. Sounds like you kind of have that down. All right, so that's y value of 5. So you can make a little better sketch now. You can say, okay, 0, 5 is your y-intercept, and we had -1, 6 was the vertex. Okay, to find the x-intercept, let me snip this in again. What was the difference about the x-intercepts? What do? You don't put 0 in for x. Where does 0 go this time?
You set the entire thing to 0.
Yes. Now this one requires a bit more work, but you can do it here. It does probably make sense to put the 0 on the right. And you undo addition and subtraction before multiplication and division. So in this case, that means undoing addition by 6.
Yeah, so it'd be -1. Absolute value of x plus 1 equals -6.
Yes. And then next thing is to undo the negative outside the absolute value. How do you do that? How do you remove this multiplication by -1? Why do you undo addition or subtraction with addition?
Would you divide it by 1?
By -1. You divide by the number that's in front. Okay, so now it's absolute value x plus 1 equals 6. Go ahead and solve that from here. It's a lot like the last one.
X equals 5 and x equals -7.
Yes, very good. What is the y value for each of these x values?
0.
0. Trying to help you out here. Not overthink it. These occur on the x-axis. They occur when y is 0. All right, so we don't have time for a full question, but we can certainly do a couple of things here on this last one. So new function for you. I want you to first find the y-intercept for us, please.
Would it be 0?
It is.
Okay, because I was making sure I did that right. Because I was like, -3 times 1 is -3, and then +3 is 0. But I didn't know if I was supposed to change it to a +3 or.
Nope, nope, got it. You got it there. Okay, really good. We got some good practice. We're going to stop right there for today.